Hello, my friends and fellow MonoGame developers. My name is Chris Whitley, also known as Aristotle Dev, and today I would like to bring a tutorial on how to use RenderTarget2Ds in your game in order to achieve what's called independent screen resolution rendering. No, I'm not making that word up, or I might be. You never know. Um, but basically, what it means is it's a way for us to render our game to a game window at a native resolution, no matter what the size of the game window is. So if we're creating something like a low resolution pixel art game that we want to render at like 360 by 180, obviously that window is going to be very small. But users aren't going to want to play on a window that small. They're going to want like a normal size window, like 1280 by 720 or even higher, maybe even full screen. So how do we take that, our native 380 by 160 resolution, and ensure that the game being drawn is scaled in such a way to match this larger window size without it like distorting the image as it stretches or whatever. How do we achieve that? And there are a couple of methods in order to do that. One of them is using transform matrix with sprite batch draw. That's a little bit more of an advanced topic. We're not going to go over that today. Instead, we're going to talk about the one that's a little bit easier to understand and digest, and that is using RenderTarget2Ds to achieve that effect of independent screen resolution rendering. So hopefully you learned something from this tutorial. Hopefully I'm able to provide some insight to that. So with that out of the way, let's get started. I'm going to look at that, shrink my camera. And I'm working in Visual Studio Code. You might be using Visual Studio or Writer or whatever your particular IDE or editor of choice is. Whatever it is, just create a new MonoGame cross-platform desktop project. That's where I'm at now, with the only exception is I have already added content to the MGCB editor. This content I added, I've called Game Screen. This is an image that I got from Kenny's website. Kenny, if you're unfamiliar with him, he makes, hopefully you're not unfamiliar with him if you're doing game dev, but he makes tons and tons of free art assets that anyone can use, completely free of charge, licensed very fairly under the Creative Commons. Um, Highly suggest checking out his stuff. I'll leave a link to it down in the below in the description of the video. But this is an image, a preview image from one of the packs on his website that just shows like a simple game scene of for a platformer, and it has like the tiles that have been drawn, the player, the enemies, objects, all that stuff. So this is going to represent our game screen itself. So even though I'm only going to be drawing the one image to the screen, when that one image gets drawn, imagine that's you drawing all the different components that would need to be drawn, like your tiles and your player and your enemies and things like that. Um, so yeah, just for now, create a new MonoGame desktop project. And for mine, that's where we're starting. Only I've added this game screen as a piece of content. So here is our game class, and let me remove that because that's not normally there. This is our game class. The first thing we're gonna want to do right now is bring in that image so we can draw it. So private texture 2D, and I'm just gonna call it image, and then we'll come down to our load content method, and I'll say image equals content dot load texture 2D game screen. And then we'll come down to our draw method and we'll draw it like normal. So it's right back to begin. I'm going to pass in a sampler state of sampler state.point clamp. And always remember to end your sprite batch. And then in between the begin and end, we'll do our actual draw command. So we'll sprite batch draw, and we'll draw the image at vector2 0, color white. And I feel like I didn't hit record on this. I'm gonna make sure I hit record. Okay, I did hit record. So there we go. That's gonna draw our image for us. Now this is gonna draw it a little bit incorrectly. The image itself is 918 by 515 pixels. So let's say that the native resolution of our game, for this game in particular that we're doing in this example, let's say we wanted that native resolution to be 918 by 515 pixels. So we can have variables in here, int native width equals 918, private int native height equals 515. And then in our constructor here in the game class, we might do graphics dot preferred back buffer width equals native width. And then we'll do, I'm gonna copy and paste that, make it quicker. We'll do the same thing for back buffer height. Let's say native height. Then we need to apply graphics apply changes. There we go. And also for demonstration purposes, I'm going to do window.allow user resizing equals true. That way we can resize the window manually just to kind of show what the problem is that we're trying to create a solution for. So with all that out of the way, we have our game. It's going to set the window at our native resolution of width and height that we want. It's going to allow us to resize the window. We load in the game screen image, and then we draw it. So far, that's all we have right now. Let's close this warning. I'm going to do a .NET run. As soon as this runs, we should see the game screen come up, being drawn. Oh, but I didn't save. I just saw the white dot up there. I didn't save. Oh, but it's fine. It worked. It did it anyway. So here we go. Here's our game screen, right? It works fine the way it is. We're rendering at 918 by 515. The full game screen is in the window. But then the user comes along and says, I'd really like this window to be a little bit bigger. So they resize the window. And there's our problem. The game is being drawn to these coordinates, but it's not taking into account the full size of the window and scaling everything appropriately to the size of the window. So as the user makes the window bigger, they get all this blank space over there, and it kind of looks really awkward. If they make it smaller, it cuts off our game. We don't want the game to be cut off. We'd rather that image shrink down so that you can still see the full game inside the window. So this is the problem that we're going to be solving, and we're going to be solving it using a RenderTarget2D. So let's do that. First thing we need to do is actually create a RenderTarget2D. And I'm just going to call mine RenderTarget, just like that. Now here's kind of a gotcha about using RenderTargets. You want to create it and then reuse it. You want to avoid creating new instances of a render target every frame in your game, because a render target is a graphics resource, and if you're creating a brand new one every instance or every frame in your game, that's going to be a lot of memory pressure. It's going to slow your game down tremendously. So instead, what you want to do is you want to create a render target and then reuse it. So we've got our render target here where we're going to store it. Let's go down to the load content method. And in here, we can do render target equals new render target. We have to pass it the graphics device. And for the width and height, we want our render target itself to be the width and height of what our native resolution is, the native resolution we're rendering our game at. So I'm going to do native width, native height, hit save, call it a day. And there we go. Render target has now been created. So what is a render target? For anyone who's unfamiliar with the concept of a render target, is think of it kind of like a texture 2D, but it's a special kind of texture 2D, right? We can tell the game itself when it draws to, instead of drawing to the back buffer or to the screen, the game window, to instead draw all those things in memory to our render target. Kind of like being able to take a snapshot of a frame and store it inside of a canvas. I guess is a good way to describe that. So that's what we're going to be doing here. We've created our render target. Now we need to actually draw to the render target. So if we come down to our draw command, you see here we have our graphics device clear, cornflower blue, standard. But we want to tell the game to draw to the render target instead of the back buffer or screen. So to do that, we just do graphics device set render target, and we give it the render target to draw to. And now any draw commands that happen, any of the sprite batch stuff that's happening, anything we're drawing, instead of drawing to the back buffer, it's going to be drawn to this render target instead. So we're drawing our image, it's getting drawn to the render target. When we're done drawing everything to the render target, we then need to set the graphics device to now say, okay, we're done with the render target. We don't want to draw to it anymore. Now we want to start drawing to the back buffer again. That way we can draw things to the screen itself. So we can do graphics device dot set render target, and we'll set it to null. And setting it to null tells it to use the back buffer instead of a render target or something else. So we set that to null. And then I'm actually going to copy and paste this code just to make it a little bit faster in the video. But instead of drawing our image, we're now going to draw our render target to the screen. So to recap what's happening here, we are telling the graphics device, hey, don't draw to the screen anymore. Instead, draw to this render target. And then we draw our image. In this example, it's one image, but for you, this would be like your whole game, right? Everything on your screen would be drawn here in this section. And that's all getting drawn to the render target. And then once we're done drawing our game, we say, hey, graphics device, we no longer want you to draw to a render target. We'd like you to switch back to drawing to the back buffer. And it's like, okay, cool. And then we do one more draw. And in this draw, we tell it to draw to the screen the contents of the render target itself. So if we do a .NET run at this point, let's see what happens. There we go. It is drawing our render target to the screen. Now, pop quiz. Everyone loves a pop quiz. Is our problem solved? If I resize this window right now, is the render target itself going to resize and scale with the window like we want it? Pause the video if you'd like to ponder the question. I'm going to give you the answer in 5. I don't know why I'm looking at mine. I don't have a watch. 4, 3, 2, 1. If your answer to the question is nope, we still have the same problem, you are correct. We still have the same problem. We haven't solved the problem yet. We've only implemented part of the solution. So if I stretch the window, you can see what's being drawn to the screen, which is our render target, is not scaling to the size of the window. Maximize it, minimize it, or not minimize, but unmaximize. If I shrink it down, whatever, it's still not scaling. But we've got the first step out of the way. We're at least drawing everything to our render target. The next step is to find a way to draw that render target to the screen in a way that the render target itself resizes to the screen. And there's two different things that are going to happen here. We're going to have to calculate based off the screen width and the screen height how much we need to scale, depending on if the screen is more vertical like you would have on like a phone, or if the screen is wider like you would have on a desktop. And in those situations, if the resolution of the screen is not an aspect ratio that matches the aspect ratio of our native resolution, we're going to end up having to create what's called pillar boxing, which is the black bars on the right and left of the screen, or letter boxing, which is the black bars at the top and bottom of the screen. That's just one of the side effects of doing independent screen resolution rendering if you want the render target to grow with the screen without creating like a distorted stretch effect, you have to make use of pillar boxing or letterboxing. With that out of the way, let's go over how we would achieve that. So I'm gonna come down below my update method. Just this is where I'm gonna choose to do it, and I'm gonna create a before I do that, let's come up here. We need to create a new field called, which will be a rectangle, and it's just going to be called render destination, and this is going to be the destination rectangle that we draw our render target to on the screen. That's all it's going to be, but we're going to have to calculate that destination. So let's create a method, private void calculate render, can't spell, calculate render destination. And to calculate the render destination, again, like I said, this is going to be based off of the screen width and the screen height, right? So in order to do that, we need to know the size of the screen. So we can use a point size equals, and we'll do our graphics device viewport bound size, and that's going to give us the size.x will be the width and the size.y will be the height. And then from this we can determine the scale by doing float scale x. So let's see how much we would have to scale on the x-axis in order to scale our render target completely along the x-axis from edge to edge. That's what we're doing on this line here. So scale x equals float size.x, so the width of the screen divided by the width of our render target width. And we need to do the same thing for the vertical axis from top to bottom. What's the scale for that? So float scale y equals float size.y divided by render target the height for this. Now we now know how much do we need to scale to reach the edges left and right on the horizontal axis, our x scale. How much do we need to stretch to reach the top and bottom on the vertical axis for our y scale? We can't use both. Instead, what we want to use is whichever one is the smallest. That way we can maintain the aspect ratio when we size our render target. So to figure out which one's the smallest, the actual scale will be float scale equals math.min, and we'll do scale x, scale y. And that gives us the smaller of the two scale calculations that we had. Now that we know what the scale is, we can determine the size of the destination rectangle and its actual position on the screen to draw the render target to. So we can do render destination dot width, and the width of our destination rectangle is going to be the width of the render target times the scale, which also, since those were floats and scale is a float and rectangles take integers, we need to convert this to an int like that. That didn't work. Render target dot width. I'm sorry. So render destination dot width is the calculation of the width of the render target times the scale. And then the same thing for the render destination dot height. It will be the render target dot height times scale. That gives us the width and height of our render destination. Now we need to determine where to draw it at. And we want to draw it in a way, or we want the position of the draw to be in a way so that it's centered in the screen. And that's what's going to allow us to have the pillar boxing or letter boxing automatically if the aspect ratio of the screen is different than the aspect ratio of our native resolution. To do that, we'll do render destination that x equals the size of our screen divided by the width, render destination width, the width of our destination divided by 2. That's wrong. It's the size of our screen minus the width divided by 2. We'll do the same thing for the render destination y, only it's going to be size y minus render destination height divided by 2. And that will calculate a new destination rectangle for us to use. The only problem now we have is calculating this render destination isn't being called anywhere. Nothing's using that. Nothing's calling it, right? So if we actually use this render destination right now, when we draw the render target, so let's take away this vector2 0, we'll put in render destination. If we run this, .NET run, give it a second to build. There we go. We can see nothing's actually happening. Nothing's being drawn. We've now completely broke it. So what's going on, right? What's going on is we're not calculating this destination at all. Nothing is calculating it. Because nothing is calculating it, our render destination is the default for what a rectangle is, which is rectangle 0. So it's being drawn nowhere. So we need to actually tell it to calculate the render destination. Now what we can do is once we've loaded our content in, or at the end of our initialize here, we can tell it to calculate the render destination right there. And if we do .NET run, now it should render appropriately, which it does. But again, it's still not going to solve our problem. As you can see, it's still not scaling. And it's not scaling because we're calculating the render destination once, but it's not being told to calculate again whenever the size of the window actually changes. It needs to know the window changed, recalculate our size, right? So how can we do that? One way to achieve that is here in your game constructor. You can hook into the Window.ClientSizeChanged event. We'll do plus equal on client size changed. And then we need to create that method. So private void on client size change. The method signature for this is going to be object sender and event args key. So this method is going to be called every time the window size changes. When the user drags it, when they hit max mouse button, whatever. When that happens, this method is called. But we don't want it to constantly be calculating over and over and over and over and over and over, right? We really only want it to do that on the last time the window size is changed. That way we're not just constantly doing these calculations. So we need something here that's going to prevent it from just continuously running while the user is dragging around the resize handle, right? So we can come up here and create a private variable. Private bool is resizing. And then on client size change, we can say if not is resizing, calculate destination rectangle. Well, actually, we would need to do is resizing equals true. Do our logic, like calculate the destination rectangle, and then when we're done with the logic, is resizing equals false. That's how we would do that. But another thing that we might want to do is, as the user is resizing the window, what happens if they've resized the window down to a 0, right? We don't want it to get to a 0, because if it gets to a 0, then when we do our calculations in here, we could end up with some funky divide by 0 exceptions, right? So we don't want a window or height. We don't want this to happen if the window width or height is also 0. So not only do we need to say if it's not resizing, we can say and the window.clientBounds.width is greater than 0, and the window.clientBounds.height is greater than 0. And there we have it. we've hooked into this window client size changed event, and we've said, all right, when the client size has changed, if we're not already doing the resizing logic and the width and height are both greater than 0, then flag that we're doing the resizing logic, do the actual resizing logic, and then flag that we're no longer doing the resizing logic. So now let's save. Let's do .NET run. And again, it loads at our native resolution of 918 by 515 that was set for the image. We have our game screen here. It's being rendered to the render target that we set in the draw method here. So we're telling it to draw to the render target, and it draws all of our game stuff to the render target. And then we say render target null. So now we're drawing to the back buffer, and we're telling it now, as the final thing, to draw the render target back to the screen at the render destination that's been calculated. And that's here. So final pop quiz. Because the window size change event is now hooked into, and every time the window size changes, we're recalculating that destination rectangle to draw our render target. When I change the size of this window, is it actually going to solve our problem and scale the image for the game? Pause the video if you want to and think about it. I'm going to give you the answer in 5, 4, no watch again, 3, 2, 1. Let's find out. Hey, look at that. The game itself has stretched, I guess to say, to the size of the screen. And as you can see, because the game window is, or our native resolution is 918 by 515, and my resolution right now on my computer is 1920 by 1080. 918 by 515, that aspect ratio doesn't fit cleanly into a 1920 by 1080 resolution. Because it doesn't fit cleanly into it, it does create these black bars on the left and right. It creates our pillar boxing, right? So we also have, as you can see, we have letterboxing if it needs to, if it's fine for stretching on the x-axis, but not all the way up and down the y-axis. We can go like completely vertical, like this. We can go to a small screen. We can go to a bigger screen. There we go. Yeah. Hopefully this helps someone. This is a way of achieving, again, that mouth of words, independent screen resolution rendering by using RenderTarget2Ds in your game. If people would like to know how to do it using the transform matrix instead through the sprite batch, also known as like using a camera in the transform matrix from the camera. If people would like to know how to do that, let me know in the comments below. If enough is requested, I can make a video on that as well. But for most scenarios, this trick of doing it with a RenderTarget2D is going to work just fine. So that's all I have for you today. Thank you for watching the video. I hope you've learned something from this, or at least I helped you understand something maybe you didn't know, or refreshed something you knew a long time ago. Don't forget, we do have the MonoGame Discord. If you would like to join us up there, we're active on the Discord. Feel free to come by, ask questions on the Discord, hang out, chat with us. We're a pretty cool community, if I do say so myself. The link should be on the screen somewhere. I'll put it up here in editing. But with that out of the way, hope you all have a great night, or day, or afternoon, wherever you're at. And I will see you in the next tutorial. Later.